Hello, everyone. Can everybody hear me? All right. It's recording. Just making sure. Can everybody see my screen here? Can everybody see the Canvas screen?
Yes, we can see it.
All right, awesome. Excellent, thank you. All right, let's just hold on for a few more minutes. See if more people show up. All right, can I see a show of hands if you are in section 1? CS 5610, section 1. All right, got 1, 2. Anyone else? Okay, quite a few. All right. Section 1. All right. Okay. Perfect. Okay. All right. Can you lower your hands? All right. How about from section 2? All right. All right. That's a few. All right. Okay, can you lower hands? About section 3? Okay. All right. Good. Thank you. All right. Excellent. Thank you, everyone. Welcome. This is graduate level web development. It's an online course. You are not required to come to these live lectures, although I strongly encourage you to be here and see this live. We are going to be doing a lot of live coding here together, and I'd like to keep it as interactive as possible. If you have a question or you have a suggestion, or if I run into trouble and have a bug, I'd love to hear raise your hand and give me a shout out and give me a line. Okay. Right. Yeah. So we'll be together for the next about 14 weeks, and again, it's a full packed course, and it's very fast moving, lots and lots of coding. So please make every effort to stay on top of the material, even though coming to this lecture is not required, and it's a fairly asynchronous course. There are some dates and some due dates that you have to be aware of. There are some time-sensitive assignments and quizzes and exams that even though you might not come to the live lecture, you still have to be aware of these due dates. Now, many of the quizzes and the exams, those again, they're going to be online, and they're not going to be synchronous like it would be if this were a live course on campus. These exams and quizzes usually will be opened up for a few days, and you can take them whenever you can within those 2 or 3 days that they're available. So again, it's very asynchronous, but I still encourage you to come to these lectures live. But I do know that these times do conflict with other courses that you might be taking. And again, because these are asynchronous courses, there's no one particular time that I can choose that would resolve the conflict. Right? If I move it to another day or time, it'll conflict just with some other folks with some other courses. The section in your you should see the section in your My NEU, the courses that you're registered. It should say 01, 02, 03, or whatnot. Okay. All right. Yeah. So let's take a look at the syllabus. Right. It is available through Canvas. If you log into your Canvas, the syllabus should be available right at top, and it has certain descriptions of what the goals of the course are, and in particular has access to the team that is going to be helping you out. Right. So this is the instruction team. There's quite a few of us, a lot of TAs. It is a big class, right? It has several sections. So we have I think we have enough TAs to help us out. There's quite a bit of options for you to choose, hopefully, for your schedule. These are all EST times, and TAs have provided here links to their Zooms or their Teams, right? That you can click on. Your screen is not on syllabus. Do you not see the syllabus? Can everybody see? No, can't see the syllabus? Oh. Share, stop share. Oh, maybe this one. How about now? Can you see this? Can you see the screen now? The syllabus? All right, excellent. Thank you. Oh yeah, I have two screens. Yeah, so I guess I was sharing the screen number one, and I really have to share screen number two. Yeah. So the syllabus. One of the most useful resources is that you have a map of different TAs that are available throughout the week at different times in the day. I, for one, have availability during the morning. But there are folks are available on Mondays, on Saturdays, on Sundays. Since all the assignments are due on Monday, I'm trying to convince some of my TAs to cover also the weekends. But also we're going to try and cover a lot of support during the Mondays, since the assignments are due Monday and evening. Folks tend to work quite a bit during that day before the due date. So we're going to have several coverage. We have 4 office hours for folks to help out during that day. So the agenda is it's full packed, and so I'd like to go over the overall structure of the course. In general, the course is split up into two large buckets, two large pieces, right? The first one that's going to be targeted the first half of the semester is learning how to create user interfaces, right? Where we're going to be learning about HTML, CSS, React.js, JavaScript, routing, navigation, maintaining state in the client application during the browser. And then the second half of the semester is going to deal with creating a server, the server side, the middle tier, where we're going to be able to handle requests from the client, posts, puts, deletes, gets, so where we can retrieve data from the server or communicate with third-party APIs and retrieve, we can query those APIs, right, and retrieve data that we can then use to render our user interfaces dynamically. We're also going to learn how to be able to log in, register, maintain multiple users logged in simultaneously, have users interact with one another, right? So that's all middle tier server side logic, right? And we're also going to learn in the second half of the semester is how to store data permanently in a non-relational database, MongoDB. So that's roughly the two parts of the course. The first half, again, user interface. The second half, middle tier and data storage. There's also at the end of the semester, there's a project that is due where folks can get together in a team and collaborate and build something that you get to choose. Right? You get to choose. So let's go through the agenda and kind of give you a rundown of what to expect. So there are 6 assignments that are going to be targeting different skills, right? That by the end of these assignments, hopefully you'll have the skill set and the confidence, right, to feel like you can build anything, right? The sky is the limit. So the 6 assignments are built around first giving you a skill set or a particular set of skills, right, and then asking you to apply those skills to build something, right, across 6 assignments. So all 6 assignments are we're going together, right, build an application, right? In particular, we're going to build this application, right? The Canvas application. I'm not going to call it Canvas. I'm going to call it Canvas with a K and a B. And so we're going to pick out a few screens from this application. We're going to take a look at the home screen. We're going to take a look at the assignment screen and the grades, right? Also be able to maintain folks can be able, we're going to be able to log in, right, as a faculty or as a student. And while they're in their accounts, they should be able to look at their profile, right, and be able to edit their profile. And while they're looking at an assignment, we're going to be able to create a new assignment, right? Be able to edit the description of an assignment, and all sorts of fields, also all sorts of properties that we're going to be able to edit, and then being able to delete an assignment or update an assignment, move it around, right? So we're going to be learning all different skill sets that we're going to be learning how to build something like this, right? Obviously not to this extent, but hopefully by the end of the 6th assignment, you'll feel that, sure, I could build this. I could totally go and finish up my assignments, right? And and implement all the various features of an application such as this. So we're all going to build the same thing together, right? Throughout the first 6 assignments. At the end of the 6 assignments, again, hopefully you'll feel comfortable enough to build anything, right? And so there's a final project that together with 4 other teammates, you'll decide what you want to build. As long as it's you keep it, clean and PG-13, whatever you want to build, that's fine, right? Obviously, there's a minimum set of requirements that we're going to go over together. For instance, everybody's need to be able to register a new account and log into your profile and change some personal information, and you need to be able to interact with a third-party API and find other users and create a kind of like a small little social network around this API. Okay, so anyway, that's at the end. So let's first go over the 6 assignments that hopefully will give you that confidence for you to feel like you can build anything. So the first assignment 1, all assignments are 2 weeks long, right? Except this first one, because this week's is weird, right? It's only half a week, right? It starts off on the kind of like the second half of the week. So, but it's fine because the first one is fairly doable, and I'm also going to give you a hand and get you going with the assignment so that you feel free to reuse as much or none, right, of the source code that we're going to be working together here in class. Feel free to reuse as much or as little as you want from the source code that I give you. So this first for this first assignment, we're going to be learning some really basic user interface skills, right? We're going to be learning about HTML as a static language, ASCII text language that allows us to build user interfaces, right? Create headings and paragraphs and tables and lists, right? And also allows you to implement navigation between multiple screens, creating forms so folks can enter data into the user interface. So some really, really basic stuff, right? Also, we're going to learn set up a development environment. We're going to download Node.js, right, and set up a small little server where we can host our application locally on our machine, on our local development computer, right? And we're going to learn how to share that source code in source control in Git, right? And then be able to submit that as our assignment, right? We're going to also deploy this very first assignment, this first web application that we're going to get started. We're going to deploy it to a remote server called Netlify, so that you can show off to your potential employer what you've been working on, some cool stuff that you've been exploring and whatnot, right? So hopefully this will be a portfolio that you can share with potential employers, saying, look at all this cool stuff that I've been working on. Yeah, so this first assignment is setting up the development environment, creating a simple user interface, committing this to GitHub, and deploying this on a Netlify server. So that's the first assignment, and that's due on the 18th, right? So a little over 11 days, right? So we'll get you started doing this. Then in this first user interface is going to look pretty ugly, right? It's going to use the standard out of the box look and feel that browsers provide, right? It's the default look and feel, right? Using Times New Roman, everything's black on white, and so it's very, very simple. In the second assignment, we're gonna revisit, right? We're gonna revisit what we worked on the previous assignment, right? And now we're gonna make it much more prettier, right? We're going to use CSS. It's another language we're gonna be learning, right? That's gonna allow us to paint, right, and make our user interface a little more palatable, right? A little prettier, a little more professional, a little more polished, right? And first, we're going to learn to use plain old CSS, the selectors and all the different transformations and properties that we can configure to make things pretty. And we'll quickly learn that it's not very easy to make things look pretty, right? You really need a knack, you really need an artistic eye, right, to make things look professional and polished. So we're going to be using a CSS library that already it will make it easier for us to to apply certain stylings, right, and make things look professional, fairly easy. Also, we're going to learn how to target multiple devices, right, so that you can build one application that can easily scale to large monitors, smaller laptops, smaller iPads, right, or even phones, right. So the same application, the same screens, right, they're going to be responsive, right, and be aware of the size of the screen, so that it can expand and contract, right, and adapt to the different sizes of the screen, right. So that's all in the second assignment. Make things look prettier, and that's due at the beginning of next month. So for the third assignment, right, so up to this point, right, for the first and second assignment, the content is static, right? It's static HTML, static CSS. Even though we are implementing buttons and forms that folks can fill out and whatnot, everything is static, right? It doesn't change over time, right? It doesn't respond to user inputs, right? So the text, the content is static, right? It cannot you can't compute anything just yet, right? So in the third assignment, we're going to fix that, right? We're going to introduce JavaScript as the language that can execute inside of a browser, right? We're going to be using the browser to render our user interface. So JavaScript is going to be able to execute within the browser and programmatically, right? Modify the user interface, respond to user input as you move your mouse or you type, right, or you drag and drop, and as you generate events to the user interface, right, JavaScript is going to be used to handle all these events, right, and manipulate some data structures in the background, right, that can then be used, these data structures, to then compute what the user interface will be, right. So we're going to learn how to use data-driven applications, right. We're going to create JSON files and arrays and objects and fairly complex data structures that can be used to compute what the user interface is, right. They're going to represent the state of the application, which varies and changes over time as user interact with the application, right. So we're going to learn about JavaScript. We're going to learn about React.js, and basically React.js, what it is, it's a JavaScript library, a fairly popular JavaScript library that can take as input a data structure, right, and then calculate, right, what the user interface looks like, right. So it basically transforms data into a user interface, right, and that user interface can then send events to change that data, right, and then that data can be used to re-render the user interface, right. So there's this cycle, right, that the user generates data, right, and that data gets transformed into the user interface. New posts, or delete something, or you change a module or assignment or a quiz, or add a question, remove a question, change the question order and whatnot, right. We're also going to learn how to navigate, right, using React.js, because one thing that we're going to lose, from our first assignment. We're going to be implementing navigation on our first assignment. But one of the things that we're going to lose when we get to the third assignment is that we're going to lose that mechanism of navigation, right? So we're going to have to rebuild that by using a particular library called the React Router library, right? That is going to replenish, right, that capability, that behavior, being able to navigate and have multiple screens and break out, large application into multiple little screens and components and whatnot. Okay. So the fourth assignment is going to expand on React.js, and is going to tackle a complex challenge, right, of as an application grows and has multiple screens, oftentimes the screens need to collaborate, right, where some data that is being generated or be manipulated in one screen needs to be available in other screens, right? So we need state that is not only within the scope of a particular screen, but it has a higher scope of the entire application, right? So the state that is changing over time needs to be shared among multiple screens, multiple components, right? So for that, we're going to be introducing a library called Redux that is going to allow us to maintain application level state, right? That can be shared amongst multiple screens, multiple components. Okay, so that's the fourth assignment. And more Redux, more React, more in the routing, of course, more HTML and whatnot. So this now on the 7th week, right? We will have reached halfway point of the course, right? And so it will be time for our first exam. And so what we'll do is that we're going to have the first half of the week. We're going to review prior exams. We're going to see sample questions that are representative of what you can expect for this first exam. Okay, and then in the second half of the week, right, we'll have the exam. Well, the exam will be released. Right, we're going to release the exam, and then you can. I think we'll release it for I think it'll be available for 3 days. It'll be available like Thursday, Friday, and Saturday, something like that, right? And you'll need 100 minutes to yourself to be able to take the exam on your own, but it can be any time within those 3 days, right? Now, up to this point, you will have worked on 3 assignments, right, and gotten started on the 4th assignment by the exam. So you'll have quite a bit of skills already accumulated by then, right? Also, you'll have taken at least 2 quizzes, quiz 1 and quiz 2. So you'll see some sample quizzes, the types of questions that you can expect. Most of my questions are multiple choice questions and fill in the blanks questions that they're all on Canvas, right? So you'll need a laptop, you'll need a desktop, right, to take these quizzes, right? They're all self-guided, they're all self-grading, right? You fill in the blanks. Usually what I'll do is I'll give you a snippet of code that has a lot of blanks in it that you have to fill in so that it behaves in a particular way, right? I'll explain, I'll say, oh, this code does this, right? It's supposed to do something. I'll give you a behavior that if you click here and you click there, this output comes out, right? And so what you need to do is fill in the blanks so the code does what it says that it's supposed to do. Okay. So a lot of questions like that. So you'll see several examples of those kinds of questions, and then the first exam is basically one really long quiz, right? Well, there'll be some questions about HTML, about CSS, about JavaScript, React.js, routing, maintaining state, and things like that. Okay. So that's that would be on the 7th week, all right? All right, so when we come back from that exam, we'll be ready for the second half of the semester, right? And again, we'll have completed, right, all the user interface skills that you'll require, right? We'll continue, right, with additional user interface skills, but the second half of the semester is going to focus more on the server side, right? By the time we get to the 4th assignment, you'll realize that applications that entirely rely on the browser, right, have limitations, right? It's applications that run on the browser are limited by what the browser allows you to do, and there are certain security concerns, right, that the browser limits what can be done within a browser. For instance, we don't have access to the file system, right? We don't have unfettered access to the network, right? We don't have a database, right? So there's a lot of limitations of what you can do within a browser. Sure, I mean, you can do a lot of really cool user interface kinds of stuff. You have forms and you look pretty and you can render lists and tables and whatnot, all this dynamically. But you're restrained with the kind of data you can work with, right? So that's where we're going to be introducing Node.js. We're going to create our own server, right, to complement some of the limitations we have with the browser-only application, React.js only applications, right? We'll create a server that can run on a desktop, right? Also implemented as JavaScript, but because it's running on a desktop, it's running on an operating system, not within a browser, not within the constraints of a browser. Now you'll have unfettered access to the file system. You have access to a database. You'll have access to network resources, right? That you would not have inside of a browser. So we're gonna learn how to create RESTful services and handle HTTP requests from React applications. So the React applications, as user type and move the mouse and interact with the application, is going to generate a stream of HTTP requests out to the server, and the server is going to receive all these requests, right, and is going to generate or respond with data, right, that of new posts that you've created or things that you have deleted or you have updated. So now the state of the application is going to be shared amongst both sections, right? Parts of the application. The client on the browser is going to have state, but also the server is going to have state, right? And there's challenges with that, right? How do we synchronize that these states are in sync, right? That they don't contradict each other, right? So we're going to learn how to maintain state on the server as well. With that as well, we're going to be learning how to manage users, multiple users that might want to create an account, that want to be able to log in, and learn all the challenges of maintaining multiple sessions for one server, right? So because our application should allow multiple browsers, multiple clients simultaneously logging in and using the server, each one having its own session, each one having an independent conversation with the server. And so how is it that the server can maintain this state information from multiple users? So we're going to learn how to do that with using cookies and HTTP session and things like that. Okay. And finally, the last set of skills that we're going to learn is, where do we store all this data that we are generating, right? All this data needs to be stored somewhere, and browsers can't do that. The servers can, but they can only store it maybe in a file, certainly, and if they can store it in the memory of the server. But the best place to put it is in a database, right? So we'll be learning how to create a MongoDB database, where we can provide a permanent long-term storage solution for our application. Okay. Right. Yeah. So that's it. Right. So those are all the skills that we're going to be learning throughout the semester. The last couple of weeks, what we're going to do is that, having completed the 6 assignments and having acquired, all these skills, we're going to now ask you to create your own project, right? To create teams of at most 5 students, and to pick a project that you want to build, right? Something that you want to create. Now that you have all these skills, right? You should be able to say, "Oh, I can build anything." So come up with an idea, and so these couple of weeks, these last 2 weeks are going to be demonstrating how you would go about starting from scratch, right? And creating a brand new application. We just finished, throughout 6 assignments, building something, but now it's something on your own. In the 6 assignments, we were telling you what to build and how to build it, right? The project seeks to confirm, right, and evaluate your capability of doing this now on your own, right? So the assignments is kind of me telling you how to do it, right? And then the project is me watching you now do it on your own, right? So it has those 2 aspects of learning, right? Watch me do it, okay, and now I watch you do it, right? And I confirming that you do understand how to go about building something. So the application that I'm going to be building is going to be a small social network, a tiny little social network around the Napster API. So Napster is a music related API that you can search for songs or artists and albums, and you can go fetch some album cover art, right? And you can query this and browse through their API and download all this data and display in a user interface. So I'm going to build a little Napster related application that that allows me to interact with the Napster API, right? We're going to be able to search for songs or for albums or for artists, right? And then I'm going to be able to navigate to that particular song or album. I'm going to be able to like the song or the album or leave a review. Or notice that some other users might have reviewed that same album, and I can read their review. I can maybe reply to that review. I can navigate to that user's profile and see other songs that they like, right? And maybe I can follow that user. Maybe I can leave a comment and leave a message to the user, and I can see all the users that I'm following and all the people that are following me, and I'm sending them messages and they're sending me messages, right? So it's kind of like a small social network, right, around the topic of music, right, the common topic of music. And so this will give us a chance to kind of cement all these skills that we've been going through for the last couple of 6 assignments, and feel like we can actually build anything we want, right? And the intent is for you to do the same, right? You're gonna choose a topic of your own, a particular API. It could be about movies or about books, or about food or sports, right? Or the weather or stocks, right? So whatever topic you can choose, there are a myriad of APIs out there that give you free information, right? That you can query, right, and build a social network around. Okay, so that's the project. We will cover the specific details of the requirements a little later. Also, it's never too early to get started on the project. Okay, so I would get started right away. Looking for teammates and choose a topic. Find an API that you can work with that's going to work for you, and start learning about it, right, and how to use it. So yeah, I would get started right away. Okay. So the project is due, I believe, right after you come back from Thanksgiving, which I believe it's this week, Thanksgiving, or this week. So actually, I need to add Thanksgiving as a holiday here somewhere. So one of these weeks we'll probably miss a day, right? Probably the second half of the week we'll miss it. We'll have the class earlier that week, right, on Tuesday maybe or Monday, but we'll miss the second half of that week. So I believe it's this week, or maybe it's this week. We'll see. I'll update the calendar to reflect that. But anyway, so right when we come back from the Thanksgiving break, or maybe a week after, you will demo the project to a TA, right? So TAs are going to share a spreadsheet where you can register your team for a time slot where for at most an hour, right? You'll demo your project to a TA, and there's a list of a checklist, right, that they're going to go through with you of all the things that the requirements that you're expected to have completed, right? That checklist is available on Canvas. And they're going to ask you, well, demonstrate this, demonstrate that, demonstrate that you can log in, demonstrate that you can follow someone, or somebody can follow you, or that you can like a movie, or leave a review, or send somebody a message, or whatever, right? So those are the requirements. And you're going to demonstrate it yourself, right? So you can follow a script. Okay, so so there's a question. So what will be the team size for the project? So there's a maximum of 5 students are allowed to get together and work and collaborate. But if you want, you can also be a single person, right, working on your own. That's totally fine. That's totally doable. As I will demonstrate these 2 weeks, I will complete a project during those 2 weeks, and you should be able to do the same, right? Now, not to say that you should wait till we get to week 11 to get started on the project, right? Hopefully you get started much earlier than the 11th week, right? Hopefully you get started right away. Ideally, as we complete a skill set, right, of a particular assignment, you should be able to get started on the project right away. It says, ooh, I know how to create screens. Let me start, creating prototypes, right, and some mock versions of these screens, what they might look like, right, and get going, right, early on, as early as possible. Now, about the team size. So first of all, it is okay to work with students in different sections, right? At the end of the semester, when you're going to fill out a form, a survey, where you're going to list all your team members, right? And you're going to say also, what section is each team member, right? It's going to make it a little bit harder for us administratively, because we're going to have to, once we have the grade, we have to go in and enter the grades in different sections, different students, and it's a nightmare for us, right? But we want to give you that opportunity, especially being remote and being geographically dispersed throughout the world. You might have other folks in different sections and that you might want to work with. So second, the other issue is that the size. So larger teams tend to be harder to coordinate, right? And usually in larger teams, there's always one, maybe two students that kind of go MIA or kind of don't pull their weight. Maybe not necessarily because they're lazy or anything like that. It's just very complex, to manage large teams, especially if they are remote, right? And they're not physically in the same room. And if it's okay if the team is very senior, right, and have a lot of experience working remotely, but early, younger teams that don't have a lot of experience, oftentimes, they're kind of waiting for someone to tell them what to do, and they might not have the initiative to get started and ask questions and see what other people are doing and whatnot, right? And so things linger on, or people assume that other people are doing certain things, but they're not doing it. And everybody's got a different schedule. So I want to discourage you from large teams, okay? Unless you trust these other team members to pull together and pull their weight, right? If you fully have worked with someone and they know they're trustworthy and you can count on these folks, and you don't mind them maybe taking a break here and there, then I would discourage you from large teams, right? I think the ideal team size is between 2 and 3 team members, right? I think that's the ideal team size, but it's totally doable by a single person, totally doable. So yeah, but large teams, it's okay, right? If you trust your teammates. Okay, so yeah, so this week is a demo week, and it's the week before the last day of classes, right? So we'll have the final exam the week after that. I believe for undergraduates, it's not during class time, right? We have to schedule a separate date in a separate room. But for graduate students, we are encouraged to do the exams the last day of class, right? And I believe that's on the week of the 12th, right? So 12/12. So it's that Monday. I'll make the exam available, and you'll have a couple of days to complete the exam. Again, the exam is self-graded. Now that the second exam focuses mostly on the second half of the semester, but there might be a sprinkle of questions from the first half in there, but mostly the second half, right? So servers, databases, right? Maintaining state on the server, logging in, creating APIs, RESTful APIs, data access objects, right? Schemas, how to interact with the database and whatnot, right? So mostly that second half. Okay. Let's see. Yeah, so the graduate level classes say the last day is the 16th, and but it's way too close to the when the grades are due on the 18th. There's no way that in 2 days I'm gonna have everything graded. So I'm giving myself about a week to make sure that we have all the projects graded, all the exams graded, so that you have some feedback, and you can give us some feedback, and whether you think in a particular question is wrong, or that you can you can challenge a particular grade. It says exams need to be completed in a single. Yes, exams need to be completed in a single sitting. Yep. Yeah, you cannot pause or resume later. So you'll have 3 days, from which 3 or 4 days, but once you start it, you have to complete it. Yeah, and it's 100 minutes long. Yep. All right. Okay. Yeah. So that's the agenda. They are proctored. They're not proctored. We will be available during the TA hours. If you have questions about the exam, you can join during those TA hours, and you can stay the during the whole TA hours if you have a question about a particular question, right? And we'll be able to answer that during those office hours. Yeah, you can feel free to join at the final exam date tentative. So it'll be made available on the 12th, and then it'll be available for 3 or 4 days, and you can choose to take it anytime during that time zone. Okay. Again, all this is remote, asynchronous. All right. All right, excellent. So let's keep going. Do we have a teammate from different section? Yes, you can have a teammate from a different section. Oh, 12/12 is a Tuesday. Thank you. Oh, of course. Yeah, this is the Monday. Thank you. So this is 12/11. All right. Let's talk about what is web dev. All right. So let's talk about web dev. So web development, is just development, right? Everything that you've been learning about in other, the courses about software engineering, right? All that applies here, right? In algorithms and databases and best practices and design patterns, everything you've been learning in many other courses, right? That still applies to the web. It just happens to be that we are using web-related technologies, right? It just happens to be that we're using a browser, right, to render our user interface, right? That we are using a browser form, right, HTML form, right, to gather data from a user interface. Yes. Also, we have to take into account the fact that we are running on a browser, and you have limitations, and we have to split our application into 2 pieces, into a client and a server architecture. So we have to follow a particular architecture, right? That we have to complement a lot of the limitations of a browser with a server, right? That we have to break out of the browser by sending requests to a server that can complement the limitations of the browser. So once we have the server, we can access the file systems, databases, networks, and third-party APIs and whatnot, right? So it is development, right? It is software engineering, but applied to the challenges and limitations and opportunities that the web provides us. Okay. Now, first, let's go way back on when all this started. Why does the web even exist? So first, what the web is a particular implementation or a particular set of technologies that run on top of the internet, right? And so first, we have to answer what is the internet. So the internet is basically just a hierarchical networks of networks, right, that are interconnected throughout the world that allow multiple institutions, some private, other state-run and government and military institutions that allow an academia, right, to interconnect multiple machines, right, through this worldwide network of networks of computers that talk to one another. Now, it originated as a research project, right, to explore how we would survive World War III, right? So folks, coming out of the Second World War, folks started to, ask questions and concern, right, on how is it that we beat the Germans, right, and whatever we did to beat the Germans, that somebody could turn around and apply that to us, right? And it turns out that we beat them by bombing the heck out of them, right, and making it very hard for them to communicate and travel and coordinate counterattacks, right? And so we were concerned that at some point somebody might do that to us, right? That somebody would invade us and make it hard for us to communicate and travel and create a counterattack to an invading force, right? So during the 60s, there was a lot of resources that the Department of Defense was allocating to answering that questions, right? What kind of telecommunication infrastructure would we need, right, to be able to survive an attack on the homeland, right? So folks explored all sorts of ideas and protocols and ways of communicating and distributing networks, right, to make them very, very redundant, so that there would be no single point of failure, right? That there would be no single place that you could bomb or destroy, and it would render us powerless to communicate and organize and organize a counterattack. So there's a lot of research on creating these very robust, very redundant network of computers that can always find a way, right, to communicate from point A to point B. Slowly this network grew out of its military application into more benign applications, right, where we out of the Defense Department labs, right, we slowly start to include much more benign institutions such as academia and other non-belligerent institutions, research labs, and even other countries, other universities, international universities, international research institutions, right? So it became much a broader undertaking, right? That wasn't only the Department of Defense, right? Now, as this grew and more people became aware of the internet, right? So Tim Berners-Lee, way back in the late 80s, early 90s, inadvertently, very innocently, created the World Wide Web, invented the World Wide Web, right? Now there were already lots of tools before the late 80s, right, that allowed multiple users to interact and coordinate and communicate and send information across multiple networks, across multiple machines. Folks could telnet and log into remote machines to download files, right? They can run tools to send messages, compile data into some graphical representation, into documents, into graphs and whatnot. So there's already this infrastructure, this internet infrastructure that had tons and tons of tools and servers that allowed the communication and sharing of information across multiple users, but it was fairly clunky, right? And so what Tim Berners-Lee tried to do was to grab all these ideas of how you can go fetch data from a different server, download it, compile it, make it visible, right? And these, what you would normally need 2, 3, 4 different tools, he came up with the idea of merging together a set of related tools, right, that would allow him to share research papers, right? He, the thing that he was trying to solve was that I'm a physicist, right, working at CERN, and I have all these really great research papers that I want to share with my colleagues, right? And right now it's very clunky, right, of how to download all these research papers and compile them and view them and download them and share them and to other folks. So he wanted one single place where you can go to a server, right, put the URL where the document is, and the document would be downloaded and automatically rendered, compiled, and viewed in what he called a browser, right? And the formatting of these documents would be a standard format that would be easily understood by anyone, right? That could be edited with a simple text editor. It didn't have any kind of binary implementation that needed to be compiled and interpreted, right? Just anybody could just open up an HTML document and edit it with a simple text editor, right? And he needed a particular server that would allow you to just type a URL. It would fetch the server. The server would look for this document in the file system, in a remote file system, and it would serve these documents that would be then fetched by a browser, which would then compile and interpret the HTML and render the laid out formatted content in a browser. He also wanted to be able to, if enough folks use this format and this technology, folks could share all sorts of research papers, and he would want to be able to link them together so that if I'm reading a research paper, typically at the end of a research paper, there's a whole bunch of references, right, to other research papers, right? So he wanted to make it convenient for you to just click on a research paper and then go fetch that document, and you could navigate between research papers and whatnot, right? So inadvertently, right, very innocently, he discovered or invented the foundational technology, right, that we now know as the World Wide Web, right, or the web. Okay. Now what it did, it lowered the bar of entry, right, of creating content and sharing content for academia, right? And students and new professors all over the world started, jumped on this idea, right, and started creating their own content, right? So folks jumped in this bandwagon, and it just exploded exponentially. Folks creating HTML content and linking things together, right? And it just grew exponentially, and the rest is history, right? So anyway, so he invented the idea of a browser, of a HTTP server, URLs, HTML, and linking together these documents. Now, there's some milestones that are worth noting on how things evolved over time, and some of the technologies that evolved and are worth knowing about. Certainly the 1960s is when we see the beginning of the interest of creating this worldwide network of networks of connecting multiple institutions and all the different protocols and infrastructure and technology that were invented during the 60s, right? During this time, we invented all sorts of way of organizing all these machines, all these computers that were being connected, right? And one particular architecture became much more most prevalent. What that we today would refer to as the client-server architecture, right? Where you have all these millions of computers that are connected to this internet, but some computers have a particular role, right? And they generally fall into two categories, right? These are all computers, right? They all have the same capability of connecting to a network, but some computers are more powerful than others, right? And they are usually either a client or a server. Now, this idea initially came from the fact that computers were very expensive, right? And powerful computers were more expensive, and usually they were huge, and they had to be housed in their own separate room with air conditioning, and you had to maintain it, and you have to babysit it, and that whereas most everybody else they had some kind of rinky-dinky small little terminal, right, that had just a keyboard, right, and a small monitor, an amber monitor or a green monitor that didn't do much, right, but it mostly just sent out requests that you would type, would send it out to this centralized, powerful machine, right, that would do all the computation, and then it would generate a response back that the client would receive, and then render the response, the results of that computation on the client. Also, it was very common if folks were sharing a resource, such a print, like a printer, that usually was shared amongst multiple users, right? You would have multiple clients sending requests to print something, and this would go out to a dedicated machine that was a server, right, that had connected to the printer, and then this would queue up the requests, right, and then print out. So you have multiple clients using the same server, right, and they print connected to a printer. Also, file servers were also very common, right? These terminals, there were computers were expensive back then, right? So also, memory was expensive, databases, storage was expensive. So you had these dedicated, powerful machines that were where you store all the files and the data and whatnot with the single repository. And then you had these, cheaper, less powerful little rinky-dinky terminals, clients that would fetch the file from these file servers, would download it so that you can view that file on these smaller computers. Now, this architecture, served well under those conditions, right? On those limitations of costs and computing power and whatnot, right? Now, these costs, started coming down, and CPU power started, growing exponentially, following, Wright's law, now we were able to create more powerful personal computers, right? Where these were now powerful enough that would fit on a small, desktop, right? That you could take it home with you, right? And instead of, and that didn't rely now on a centralized, powerful machine, right? You can install the software right on your desktop personal computer, right? And it runs locally on your machine, right? And it didn't rely on some, powerful server. And so this changed quite a bit the model and understanding of, what could you do with a computer, right? Also the model of how you deploy software. It used to be that you deploy it in a single centralized computer, and then you have smaller terminals just run their applications on this centralized computer, right? And then these terminals would just display the results. Now, on a personal computer, you can run, your desktop on your personal computer. You can run the whole application just on your own, right? And you don't have to have this powerful machine, centralized machine, right? Now, in the 90s, with the advent of the World Wide Web, we kind of went backwards a little bit, right? Now we go back to the client-server architecture where you have these browsers, kind of taking the place of the terminal, right? The dumb terminal that can render anything. It doesn't really do any computation, but it sends all the requests out to some server the server executes and then comes back with the content that gets rendered on the browser. And so there was a huge boom in the 90s, right, of just pushing the limits of what could be implemented using this new idea of browsers and servers, right, and HTML, and folks, trying to invent what could you do with these types of applications, and people, started, all sorts of companies were created, promising all sorts of things that a lot of them didn't come to fruition, right? In the in the 2000s, right? There's at the end of the century, there's a huge bubble that burst, and a lot of companies, web companies that turned out to be no good. But there was a lot of technology that was created that still lingers on with us today, right? So there was a lot of inventions and best practices and design patterns that was created during the 90s that stuck with us throughout the 2000s in the new century, and the realization, right, that now, this new infrastructure and all these technologies of servers and browsers and whatnot, right, was a legitimate infrastructure where you can build applications, which we call today web applications that rely on web-related technologies, right? In the 2010s, there was the advent of mobile computing, where we were now walking with supercomputers in our pockets, right? And now more and more folks accessing web content through their phones, right? With these small little screens. And since that is the largest demographics, right? That's the most people are going to consume your web content through a small, phone screen. Perhaps that's where you should start implementing your application, right? So you can cater to the most common type of clients, right, or users. What's in store for the future? Instead of phones, maybe we'll just plug that into our brains and be able to access the World Wide Web from anywhere in the world using Starlink, right? And then implement all these things that using artificial intelligence, which is if you're going to take all our jobs, right? Who knows? I don't think so. I think AI and ChatGPT and all this, I think are going to be technologies that are just going to multiply our capabilities of being productive. Where we've been trying to code ourselves out of a job, right, for several decades already, right? We've been automating processes like crazy, right? If you work anywhere, you realize that most jobs is creating all sorts of automation, right? Automating processes, of improving the client's experience and being able to self-serve, and so we've been trying to automate our way out of a job for a while, right? And this is just going to accelerate that trend exponentially, right? Where now our fingertips is we're not just us developers, but we have an entire team of developers at our fingertips, right? Where we're coding not for just ourselves, but dozens, hundreds, thousands of developers, right, at our fingertips, to create all sorts of really, really interesting and really powerful software. Okay. Anyway, so this is a map of the internet. We have all sorts of millions of clients that are connecting to servers to run their applications, and these servers or clients are talking to other servers and other clients, right? Fetching data from all sorts of places, right? And they're in between. You have this infrastructure of network connectivity that we call the cloud or the internet, right? So we're going to focus on one of these corners, right? We're going to zoom into one of these corners, and this is kind of what we're going to be building throughout the semester, right? We're going to first focus here on the client side, and this client can be all sorts of things, right? It could be if an iPhone application, an Android application, right? It could be a desktop application. It could be a game application running Unity or something, right? We're going to be focusing on a particular client implemented using a browser, right? So a browser is going to run some code, right? That is going to dynamically render some content, right? That is going to be responsive to the size of the screen. It can adapt to the size of the screen or the device, and also listen for input from our fingertips, moving our mouse, typing and whatnot, right? Filling out forms and maintaining some kind of state that gets rendered into a user interface that responds to user input. So that's this first half. We're going to be focusing on this side, right? And we're going to be using technologies such as HTML, CSS, JavaScript, React, right? Now, in the second half of the semester, we're going to focus on the server, right? Which is going to complement the client. We're going to create our own APIs, right? That can generate data, connect to other servers that can fetch data from a third-party API, connect to a database, connect to a file system, right? And we're going to integrate these two pieces, the client and the server, using HTTP, right? Where the client generates a HTTP request, right? And the server is going to respond with an HTTP response, right? So this is this client server architecture, developed in the late 60s, early 70s, right? Has survived, right, throughout the ages. It's still a very relevant architecture on how we build, right, our applications, right? So very, very relevant today. So a little bit of history on how these technologies have evolved over time. Let's talk first on the server side, right? On the server side, technology has evolved over time. So let's talk about that first, because it is where most of the design patterns and best practices, that's where they evolved and matured first, okay? And we'll see how a lot of what matured on the server side slowly made its way onto the client side as well, right? So the things that we learn on the server and how to build these applications, right, over time, right, they eventually migrated over to the clients as well, right? So there's some parallel there, and it's useful to know what happened, right? So right when Tim Berners-Lee came up with the World Wide Web, right, and folks started to creating HTML documents with images and tables and lists and whatnot, they quickly ran into the limitations of what Tim Berners-Lee had created, right? He was looking to just share research papers with other fellow physicists, right? That's all he wanted to do. The content was static, right? The results were static, the graphs were static, and so as more and more people started to create HTML content, they quickly ran into limitations. It says, oh, it can't do this and it can't do that, right? So they started looking for ways of fixing this, right? I mean, it's not like it was broken, it was just had limitations. People were saying, well, what if I wanted to build an application, right, an HTML page that shows me the current stock market, right? Or the current weather, right? Or where planes are right now, or boats as they sail across the world. How do I build something that when I navigate to the HTML documents, it shows me the current state, right? That it's not static, it changes over time, right? We couldn't do that with plain old HTML. So folks would say, well, the main idea was, well, what if instead of just having a static ASCII HTML document, right? Because I know browsers can render HTML. What if that HTML document, instead of being static ASCII, right, was instead an executable, right, that could generate HTML, but instead of being a static HTML, I could maybe run through some for loops or if statements and branches, or maybe hits a database and whatnot, and calculate that HTML, right? Compute that HTML string, right? And then send that response back to the client, right? And so in that function, I could calculate, right, and say, ooh, the weather now is sunny, and then tomorrow it will be rainy, right? Or the stock is up today and it's down tomorrow, right? And here are where the planes are, and here's where the boats are, right? And I can calculate that HTML on the fly, right? And then respond with this dynamic HTML. Make sense? So the first idea was they could to what it's called in the early 90s, what is called the Common Gateway Interface, right? Where that now servers, instead of just responding with static HTML, now could respond with something that was calculated, right? It would you have a URL that instead of referencing an HTML static file, it was referencing some executable, and that executable would be some kind of binary that was implemented either with C++ or Perl or any other set of languages, right, that could run on the server and then respond with an HTML content, right, that was calculated by some function. Make sense? So this opened up a huge set of opportunities of what could you do now, right? And so this idea took off like wildfire. And one of the more prominent uses of this idea, one of the most successful folks that implemented this idea was PHP. PHP, allowed us to instead of using just plain old C++, because think of it, right? C++ would be it would run a function, and it basically needed to generate a string, right? Basically needed to concatenate all sorts of strings together, right? As you loop, as you have if statements, it would have to concatenate a string and then respond with a string, right? And that's very error prone, right? It's very, very easily, you can make a mistake, and it's hard to test, it's hard to evaluate and whatnot. PHP idea was brilliant, where it allowed you to, in one single file, embed HTML content, then escape and have some embedded PHP executable functions, right? And then embed some HTML code, right? That would run on the server, and it would be all blend together and calculate what this new HTML content was, and then that's what we would be responding, right? And that was, it was just hugely successful, hugely popular, right? Now, throughout this decade, right, on the 90s, there were lots and lots of companies that started using PHP to create all sorts of really cool applications. And as the industry evolved and matured, right, engineers identified, what worked, what didn't work, what were the best practices, what were bad practices, what were some of the design patterns that worked well, what things to avoid. And in the late 90s, right, there was enough of these design patterns and best practices that they coalesced into a well-known set of design patterns, right, that were first captured by Java, the Java 2 Enterprise Edition, that implemented an infrastructure that best capture these best practices, these design patterns, right? One of the more famous ones is the model view controller, right? It's an architectural design pattern, right, that says that if you're building big, large applications, web-based applications, it's better to think of these applications into, if you're building anything, any artifact that you're building, any file that you are building should fall into one of three buckets, right? The model, the view, and the controller, right? Now, in each one of these buckets has its own set of skills, its own set of concerns, its own challenges, right? And what to do and what not to do, right? So in the view bucket, it's everything that has to do with interacting with a human user, right? So human users have keyboards and mice, right? And they're looking at a screen, and they're filling out forms, and they're clicking hyperlinks, right? And they want to see things that look pretty, and they have colors, and things have to be justified, right? They want to see things with a particular color scheme, right? They have to use good design and artistic eyes, right, to things look pretty and whatnot, right? So everything that has to do with user rendering, right? So that goes into the view bucket. The model bucket, that bucket is so huge that there's an entire industry around that, right? It's all about, how do we represent the data structure, the data that is being stored and retrieved to a file, to a database, right? And how to, how best to create the relationship between the data. And again, there's a whole industry of databases, right? There's whole courses that deal with that, right? Either 5200 or 3200 deal with, how to structure the data, right? How to retrieve data, store long-term storage and whatnot. And in between, you have the controller design pattern that deals with all the events that users generate as they interact with the user interface, right? All the clicks and drags, and as they generate a stream of events, those need to be handled, from the user interface, right? And converted into some data structure and state management and updates of the model, right? That things need to be deleted or updated or created or retrieved, from the data model, all to fulfill, user interaction and events that are being generated by the view. Yes. So that's one architectural design pattern. There's many different design patterns that were, captured in the J2EE infrastructure. Then came, .NET and Ruby and Django, and every new iteration just added more, more design patterns, more ways to tackle, large projects, right? On how to best build these things. In parallel to this, there was also a lot of maturity that was happening on the client side, on the browser side, right? Which included JavaScript, the evolution of JavaScript running on a browser. And eventually JavaScript was able to break out of the browser and become its own infrastructure, also on the server, and become what today is Node.js. And that's where we're going to be focusing our efforts here. We're going to be using Node.js as our infrastructure to implement a lot of these best practices, a lot of these design patterns on the server, right? Reusing a lot of the maturity and best practices that have evolved over, several decades. Okay. All right. So all this maturity and all these best practices that were invented and matured on the server eventually made their way onto the client side, on the browser, right? First started with JavaScript, in the mid 90s, right? So, while folks were trying to say, oh, we can generate HTML dynamically on the server, right, running C++ or PHP and whatnot, right? Folks were also conversely saying, well, why on the server? Why does it have to run on the server and then comes back to us as this dynamic string as HTML? Why can't we instead run code right on the browser, right? Instead of the server sending us this string of HTML, why can't I generate the HTML right on the browser using languages such as JavaScript, right? The code can run right on the browser and manipulate, the forms and the lists and the tables and the content, render it right there in the browser. And so that idea came from Netscape, where you would have JavaScript that was downloaded from the server, with static file, right, that would then execute in the browser. And some folks balked at this, right, and pushed back heavily on this idea. Folks didn't like the idea that you were navigating to a website that would download executables and then it would execute on your local machine. Some people are kind of pushing back on this. It says, I don't know if I like that idea, right? That I'm going to allow this file to download and execute on my system. What if it's perusing through my private stuff, right? And it's going to steal my passwords or my private stuff, right? So folks pushed back on this heavily, and folks were disabling on their browser the executing JavaScript, right? Now an alternative to this was the installation of plugins that would extend the capability of browsers, right? That would allow you to allocate a particular area in your browser screen window, and allow executables to run inside of that plugin, right? That presumably would contain the execution of that code within that plugin, right? That outside of the plugin, the code would not have access to your file system. It wouldn't have access to your private information, right? And obviously there was some trust on whether you trusted those plugins, right? And whoever was building these plugins and these code, and someone who had a lot of success in this was Adobe. Adobe Flash, right, was an infrastructure that allowed you to execute binaries inside of a container, inside of a plugin in the browser that you have to explicitly install, right, the Flash player. And this was hugely successful, right, throughout the 90s. And there's tons of games and tons of educational content and movies and videos and all sorts of just hugely successful, right? And JavaScript kind of lingered on for a while, for a decade in the wilderness. But there was also a lot of in parallel, there was a lot of maturity that was happening also on the JavaScript side, where folks were also creating browsers that would also create a container where JavaScript would not be allowed, right, to execute outside of that container, right? So JavaScript would also run inside of a walled garden that would not allow JavaScript files to code to go out to your file system, or bombard you or take over your screen somehow, right? Or listening and spy on you as you interacted with this user interface. So there was also a lot of parallel maturity over the years, right? And one of the first infrastructures that was very successful was the Dojo, right? It was a library that copied a lot of what was happening on the server side. A lot of the ideas that was happening on the server side of dealing with large applications was being implemented also on the JavaScript side, right? On the browsers and whatnot. Now, around this time, there was occurred a war or a challenge amongst rivalry amongst multiple companies that were identifying and seeing that the World Wide Web was really becoming very, very relevant, right? And some companies, felt that they were being threatened a little bit, right? Their homogeny was being threatened. In particular, Microsoft, right, where their model was that there was that a lot of people had the Microsoft operating system, and they provided a lot of the software that dependent on the fact that you had the Microsoft operating system, right? So they were, they had a huge business of providing the all the software there, right? The words of the world, right? The PowerPoints, the spreadsheets, right? And all sorts of developers were developing for that operating system, right? They provided very powerful development environments and tools and whatnot. Now, with the prevalence and growing relevance of the World Wide Web, folks were starting to, and the fact that you had Adobe and you had JavaScript and you had J2EE and .NET eventually, folks were looking to implement applications that were not reliant on running on your local desktop, right? But were actually running offline, right? In some remote server, or even within the browser. And so now there was no dependency on the local operating system. It didn't really matter whether you had Mac OS or Linux or Microsoft OS, right? Windows. And so there was a lot of worry that, oh my goodness, the model of software development and software distribution and sale and whatnot and updates was kind of was morphing to something different. And so a lot of the big players saw that the browser was a very important aspect of this new model of software development and software distribution and selling, and so they vied for control or influence of which browser did you actually use. Were you using, right? Were you using Opera? Were you using Netscape, right? Were you using Firefox, Safari, Chrome, or God forbid, Internet Explorer? And they were kind of trying to differentiate amongst themselves. So, why would you use one browser or another browser? It was becoming kind of like a commodity. It didn't really matter. As long as you could render HTML, who cares what browser you were using, right? And this was this was very worrisome to Microsoft in particular, and saying, "What do you mean you don't care what operating system and you don't care which browser? We're not going to control the development cycle of software." So they pushed heavily on differentiating the browsers, right, and saying, "Hey, it does matter which browser you code for, because my browser can do this and their browser can't do it," right? And so they saw that as an opportunity to try to entice developers and saying, "Hey, code for my browser, right? Code for my server, because I can do this and these other servers can't," right? It was trying to recreate the control that they had over software development, right? In the Microsoft world, you're trying to recreate that control, but for web developments. Okay. Now they did not succeed, to say the least. But what this created was a fracturing of the browsers. Right now, developers could not just rely on JavaScript behaving the same way everywhere. Could not rely on browsers rendering identical in multiple browsers. Now you had to have code in your JavaScript that said, well, what browser am I running in? Do I have this feature, right? And you have all these switch statements everywhere, saying, oh, if I'm running on Opera, do this, right? If I'm running on Chrome, do that. If you're running on Safari, do that. If you're running on IE, then do something totally different, right? So it was same thing that already had happened in C and C++, right? Was now happening in JavaScript. In C and C++, whenever you were compiling something, you had to be aware of what operating system, what particular CPU or architecture of where you were compiling, and you had all these preprocessors, right? If it's running on x85, then compile this way. But if you're compiling on a Motorola, then do something else, right? And so the same thing was happening in the JavaScript world, right? When you had this fracturing of the JavaScript language, because different browsers did something different. So in came in jQuery. So jQuery, what jQuery tried to do is create an abstraction layer, right? That a very thin abstraction layer that abstracted out the browser, right? So that now developers didn't have to care on what browser am I compiling for, or what browser am I running on. Instead, you coded to this middle API. jQuery would figure out, instead of you having to code all those switch statements and all that logic that figured out which browser you were in, instead you code it to the jQuery API, and then jQuery would figure out, right, that if I'm under Mosaic, I'm going to do this. If I'm running on Opera, I'm going to do something else. And it created a standard behavior, across all browsers. So it was really, really great. It basically tried to do the same thing that Java tried to do, right? Java tried to create an abstraction layer on top of operating systems, right? So that you would have the same source code, presumably would compile and run on Mac OS or Linux, right, or Windows, unmodified, right? That was the intent. So yeah, but this was the first time where the idea of creating an abstraction layer, first became, predominant, right? The idea of an abstraction layer, and subsequent iterations of this idea became more and more ambitious. Knockout and eventually Angular. Angular is by far the most ambitious abstraction of a browser, right? Where you're no longer coding with just plain old HTML or plain old CSS. Now, you have these all these best practices that that we had learned way back on the server. All these design patterns and very powerful abstraction layers, right? Now we're being now implemented on the browser, on the JavaScript side, right? And Angular, implements a lot of the design pattern, the singleton design pattern, the services pattern, the observer pattern, right? All these really cool design patterns that became popular and were matured on the server side, right? Were now being implemented on the client side using JavaScript. Okay. So, and there was all sorts of iterations of the same idea of creating these abstraction layers, now and became very, very popular. Folks, this took off like crazy, and a lot of developers and a lot of companies, embraced the Angular infrastructure, to create their web applications, their very modern web applications. Now they they committed a tragic blunder when they went from Angular 1, and they learned a lot from the first version, and they created the second version, Angular 2. And the blunder was that there was no simple path to migrate from Angular 1 code, source code, to Angular 2. And now companies and developers, found themselves that, hey, all the code that I have invested on, right, all the source code that I've invested on the several years of using Angular 1, all that, if I want to move over to Angular 2, I'm just going to have to throw away all that investment, right? There was no clear path to convert that or reuse any of that if I want to use Angular 2. Right? I'm going to have to start from scratch, right? And a lot of companies abandoned Angular, and they started looking at alternatives. What other? Well, if I'm going to have to start all over, right? Might as well start all over, right? And see what other infrastructures are out there, right? And right there was Facebook React.js to welcome all these disgruntled developers, all these disgruntled companies that were looking for alternatives, and React.js was there to embrace them. React.js is a much, much simpler it's not even an infrastructure, right? It's just a library that it just makes it very simple to create single page applications, to render. It's just a rendering engine, right? Is just a way of creating a function, a transformations that in comes in data and out comes a user interface, right? So it's a way of converting some data structure into an equivalent user interface, right? And that user interface can then edit the data structure, and then that data structure then gets re-rendered into a new user interface, right? And so what we're going to learn is how to create that transformation, right, between data and user interface, and create that cycle. It's very, very simple. It's obviously not as ambitious as Angular. React has no opinion on how that data is represented, where you're getting that data from some server or some file. It doesn't have any of the abstractions that Angular has, like the service layer or all those design patterns. If you want them, sure, there's plenty of other libraries that implement all those best practices and design patterns, but it's not part of React. React is just a rendering engine, right? It's not as opinionated as Angular is. It doesn't take over the entire infrastructure, right? It's only a rendering engine, and it's really, really simple. and it's a breeze. Obviously, this is not the latest and greatest. There's many other libraries that are coming out every day. One of the more prominent today is Vue.js, is becoming very popular as well. But by far, still React.js is one of the more popular UI rendering engines out there. So we're going to stick to React.js through this course. Just a couple more points. So as I mentioned already, there's two main ways of rendering content. The first that became more prominent during this era of the server side, right, or then J2EE and the .NET and the Ruby, Python, and Node.js and whatnot, was rendering the content on the server, right? Alice here would use her browser, to request content from some server. The server would translate that request into some executable form that would run on the server and would calculate the content that would then be responded back to the browser, and the browser would render it. Okay, and this became this solution, right? The Javas and the .NETs and the Rubies on Rails and Django's and Python and whatnot, right? So that is this approach. Yes. Now, more recently, or maybe like a decade later, we have this other approach where their content can also, or alternatively, right, be rendered on the client. Right, the browser executes this instead of the code executed on the server. Right, the code executes on the browser. So you have JavaScript running on the browser, and then rendering your content dynamically with the JavaScript running on your browser. Now, obviously, we have some limitations in the browser. We don't have access to the file system. We don't have access to the database. So it does rely on the server providing the data, not the content, right, but the data, right? The server provides templates, right, snippets of code, right, of HTML, right, but the main content is being rendered on the browser. The browser can come back for data, and ask for, who's logged in and their preferences, right, and JSON objects, and it would then use that to render on the browser. Okay, so this is where we're going to be focusing this semester, and the distinction between these two approaches, I think, became apparent to me when I started using Google Maps. Google Maps. When I first used Google Maps, right, it became clear the distinction between these two approaches. Right, before Google Maps, right, there was MapQuest. Anybody remember MapQuest? Anybody? So MapQuest was basically a precursor to Google Maps, and their implementation was using this strategy, right? Where you had the same functionality of Google Maps today, but their implementation was that every time you panned, right, the map, or you zoomed in or you zoomed out, when you click and said, oh, I want to zoom in or zoom out, the request would go out to the server. The server would compute the new map, right? It would compute the entire page, right? The browser would throw away the old HTML, right? And the server would recompute the entire page, and you would see a brand new page with a map, zoomed in or zoomed out or panned, right? And that was the pinnacle of the technology, right? And it was fairly quick. It was very fast and accurate and perfect. But when I first used Google Maps is using this technology, right? This implementation, where you first navigate to the Google Maps screen, right? But most of the content doesn't get re-rendered, right? It's static, right? Or you never re-render the entire content. You never recalculate on the server right, this screen. It gets only rendered first, once, right? And then as you interact, right, as you grab the map and you jiggle around, right, it's nice and smooth, and you can flick it, right? You can flick it, and it's nice and smooth, and what the browser is doing is it's going out to the server on the back, behind the scenes, is creating all these HTTP requests back to the server, fetching more images, right, to fill in the empty spaces of the world, right, of the map, right, and fetching data to overlay on top of the map, right, and traffic jams and stores and points of interest and whatnot, right? And it's fetching all this data from the server, and it's dynamically updating the map, and it's nice and smooth. It's not a jarring interaction where you can see, like a flicker. You don't see the whole page just going away and then re-rendering entirely. You see this nice and smooth interaction, right? And more like what you would expect in a desktop application, right? It's very, very interactive, very responsive, right? And this is where most of the applications are going towards today, right? And they're usually referred to as single page applications, where you have one application that gets rendered, one page that gets rendered once, right? And then any updates are done by the JavaScript, right? And today you kind of have a combination of the two approaches, where the first query or the first access, the first page that gets rendered might get rendered using this strategy, right? Where it's the first time you come to the screen, right? You can run really fast, powerful backend servers that can calculate the first rendering, right? They pump all this content to the browser, but then subsequent queries and subsequent requests, as you scroll through the content, as you click on the buttons, as you navigate to different screens, they'll use this alternative strategy, right? Where they will smoothly transition to another screen, right? They will add content and right, and stretch things and show things and animate things, right? As you navigate to different screens, they'll use this strategy, right? So it's a combination of the two. Now, for our course, we're going to focus on this second strategy, right? We're going to use React.js and the server, right, and third-party APIs and RESTful services to, right, create React.js running on the browser, which is going to dynamically render the content, right? But we're going to have to go out to the server to fetch data, right, so that we can then smoothly render our content on the browser. Okay. Yeah, excellent. So there it is. So that's what's World Wide Web and the internet and what we're going to be working on. Let's now focus on our first assignments. Right. Let's take a short break, and when we come back, we'll take a look at the first assignment. Getting set up the development environment and get you going. All right. All right. So let's take about a 5-10 minute break. And we'll come back right after these messages. All right? Hold on. I'll be right back. All right, and we're back. Okay. Yeah. So let's continue. Any questions so far?
Hello.
Yes.
Yeah, this is Shank. So I had a question. So with React, this is what how client-side UI rendering looks like, right? So how does it look like with Angular? Like, what was the difference between those two libraries?
Yeah. So they both apply the same idea of creating a single page application, and they both have a rendering engine where they abstract the using JavaScript to dynamically render this content. So they both use that same technique, but Angular goes far beyond just only being a rendering engine. They also provide all sorts of abstractions such as singleton patterns and observer patterns and services that are very common on a server side infrastructure, right? But are not specific to user interface or like or for rendering web applications. Certainly, they're very, very useful, but they kind of force you into using the entire infrastructure to take most advantage of it. React doesn't force you to do that. It's only the rendering part. If you want to implement your own state management in your services or your observer pattern and whatnot, sure, you can go and either build it your own or use a library that will allow you to keep that feature. So they're both single page application libraries, right? But Angular provides so much more, right? It's a huge infrastructure, whereas React.js might be considered to just a library as opposed to an entire infrastructure.
Okay, thank you.
There was a question here. Hi, professor. Can we have teammates for the team of five teammates? Yes, I mentioned earlier that it's okay to have up to 5 people, even if they're in the different sections. Although I wanted to discourage you from large teams, since it does make it much harder to coordinate and make sure that everybody's pulling their own weight. Unfortunately, there's always 1 or 2 teams at the end of the semester that complain about other teammates, saying that I did most of the work and this person just went MIA and I didn't hear from this person, and now I'm concerned about my grade, blah blah blah. And unfortunately, that typically tends to happen at the very end of the semester, like the last week, when there's very little to do. You can't do much there, right? Again, I would discourage you from large teams, but sure. I mean, if you know some people that you can trust to pull their weight and be there for you, sure. There's a question. I'll double check how many teammates. Yeah, up to 5. Up to 5 members per team. Is there any resource to get to recruit our team members? Yes, on Piazza there is there's a post out there that is dedicated for asking for if anybody wants to join a team. Spring Boot. So Spring Boot is an infrastructure, a server-side infrastructure that again implements a lot of the best practices, model view controller, and all these design patterns that allow you to easily connect to databases, provides ORMs, object relational mappers that allow you to easily map what you do at the with your objects in memory, right? To very easily map them to tables and relationships between tables very easily. Yeah, definitely a great infrastructure. For the assignments, we ask you to use our particular infrastructure, right? We use React.js for the front end. We use Node for the middle tier and MongoDB for the databases. For your project, feel free to explore other infrastructures, right? So if you want to use if you want to explore Vue.js or Angular for the front end, sure, go try to do that. If you want to try .NET or Python or Firebase or something else for the middle tier, sure, you can do that. If you want to try a different database, you want to try Oracle or SQL Server or MySQL, right, for your database, absolutely. And you can mix and match, right? And so you can only maybe change the database if you want, or you can change only the front end, or you can change the Node.js for a different server, right? As long as everybody's talking the same HTTP HTML, JSON, right? Then you're good. Okay. I believe we're using version 18 of React.js. Can we implement our own API rather than relying on a third party? So you need to do both, Ben. So definitely you need to create your own API for your user interface that stores your data that you're creating in your own database. But then you're also relying on a third-party API to fetch data. So for instance, if in my Napster application, I'm going to use the Napster API to search for songs and albums and artists and whatnot. And that I'm going to render in my user interface. Now, if you write a review or if you like a song or an artist or an album, right, that data cannot be stored in the Napster API, right? That needs to be stored in my API, right? That you have to go out to your server that you control that stores the data in your database, right? And you need to maintain a relationship between the data you're storing in your database and how is that related to data that is stored in Napster. Typically, that is done by using some kind of primary key or some kind of unique identifier, right? That you can use when you store it in your database, right, to make a reference and know that this is somehow related to something that is stored in an entirely different database with a different API, right? So you're responsible for maintaining that relationship. Is it possible to switch to the on-campus course? If you're an undergrad, sure, absolutely. All right. Anything else?
Hi, Professor.
Yes.
By different sections, do you only mean sections that are taught by you?
Yes, I mean sections that I am teaching. Yes, I have no idea about other instructors teaching other courses.
Okay,
other
thank
sections.
you.
Yeah, only mine. Yes, the textbook is required as yes, I'm sorry. There is a textbook required for this course that goes into some additional theoretical things. Has a little bit of complementary content in there, some exercises, and some questions on the quizzes or the exams. Might come from some reading from the exam from the assigned text. Yep. All right, let's talk about, first let's talk about HTML. Oh, maybe another question on the chat. As a self-learner, do you recommend we get the hang of every framework or stick with one or two? I would as many frameworks as you could get your hands on. Ideally, you have tried out at least 2 or 3 infrastructures or different frameworks, and that you have at least an opinion about how are they different, how are they the same, and eventually you can create your own infrastructure, right, or your own framework, right, that you have tried so many frameworks that now maybe you have enough experience that you can create your own framework, right? And that other people will be using your framework as opposed to you using other people's frameworks, right? Yeah, so everything is in flux, everything is changing, and the only thing that is not changing is that things are changing, okay? And so we have to embrace change, right? Okay, let's talk about the assignments. So the assignment, the first assignment is available here if you go to home, in the week 0, and there's a whole bunch of slides, and you have we'll go over the slides a little later, but I just wanted you get started on the assignment, so you have this weekend to work on it. And so this first assignment is all about learning about HTML. Okay? learning about HTML. And all my assignments are divided into three sections, right? 3 distinct sections. And so the first section is labs. Right? The lab section deals with various skills that you need to acquire, understand, right? That will then allow you to go on and build something, right? And so all these labs are, most of them are very hands-on, right? Where we tell you exactly what to do, copy this piece of code, and then run it and then verify that it does this, right? And we can't hold you through the whole process, right? It's, it's very step by step, right? And with the intent that you practice these skills, right? And the exercises are very small, self-contained, right? And they make a point. They're trying to make a particular point, right, on how to do something very specific. And then in the second section, the Canvas section, you're asked to show that you understood what we just asked you to do, right? So using the skills that you just acquired in the labs, go on and build something, right? And in particular, you're going to be asked to build the Canvas application. And the Canvas application is based on this, right? It's the Canvas learning management system, which, throughout the next 6 assignments, we're going to build something that looks somewhat like this, right? It behaves somewhat like this. It has some of the features. Obviously, we're not going to get to build everything, but we're going to tackle some of the more useful and what most people use, right? Most people come to the home screen and have a list of a whole bunch of modules, and each module has a whole bunch of hyperlinks, right, and sections, and you can add new modules, you can resize and move things around, and you can collapse things, right? You can edit and remove content or move it elsewhere, right? And people can view different assignments. You can remove assignments. You can move them around. You can create new assignments. You can edit an assignment. Right? You can edit an assignment and change different aspects of that assignment, right? And then save it. You can look at your grades, right? And see different students and different assignments that are available. And then you can edit a particular grade, right? You can go into your account, right, and look at your profile and edit your profile, your name and what biography and whatnot, blah, blah, blah. So we're going to grab some of these features and we're going to build that, in the next several assignments, assignment 1 through 6, right? And this is the first assignment. And so we're going to tackle HTML, learn how to use HTML, and tackle some screens and navigate between different screens and whatnot. So, and as the assignments progress throughout the semester, we're going to come in the second assignment, and we're going to revisit a lot of the content that we created in the first assignment, and we're going to apply CSS, right? And we're going to paint it, we're going to make it look prettier, we're going to change the fonts and the background colors, foreground colors, right? And use icons so that, iteratively, right, we're going to make it look more and more so that it behaves this way, okay? Yeah, so, and then in the third section is specific only to graduates, where we have undergrads that are using the same assignment, and they're not responsible for what is in the graduate section. Only graduate students are responsible for what's in the graduate section. And usually it's we ask you to go a little further, right? And we ask you to do maybe some additional screens that explore maybe an additional skill set, right? And it's just more work, right? In particular because certainly our undergrads have a much tougher and much more work. They have different sections. They have a lot of courses that they're dealing at the same time. they tend to register for many more sections than graduate students do, and also graduates are more senior. You have more experience. Maybe you've already taken jobs, right? And so you're expected to do more, right, and explore other aspects that might be a little more edgy or in the fringes, right? So that's the intent, right? And all assignments have the same organization. Okay. So the first assignment, he gives the first set of labs. Okay. So the first set of labs is to set up an environment, set up a development environment where we can start working and building stuff, right? And the first thing that we'll need to do is to install Node.js. Node.js is going to be the infrastructure foundation where we are going to be able to work first on the user interface, and then again, Node.js that's going to allow us to build on the server side portion of our application, right? So first thing, we'll need to install Node.js. So please go and visit nodejs.org and download the recommended version of Node.js. Okay, install it, follow the instructions, and once you have that installed, you'll have a couple executables at the command line, right? Now, what Node.js is just basically, it's a JavaScript interpreter, right? It allows you to execute JavaScript at the command line, right? Usually when folks think of JavaScript, folks think of, oh, it's something that is meant to execute inside of a browser, right? And that has been, for the most part, true, right? For at least for a decade and a half, right? That has been true. But lately, well, not so lately, for at least 10 years already, JavaScript has broken out of its a browser container, right? And it has evolved and mature enough that now it can, it's meant to be used like any other mature language, right? That you can build basically anything, right? Anything that can just run on a regular desktop application, right? So Node.js is just basically an interpreter that allows you to run JavaScript, right, at the command line on a desktop, right? That's what Node is. So when you install Node.js, you get the Node executable, right? Just like if you install Java, you have the Java executable, right? And what allows you to do is run JavaScript files. You can say node and then a hello.js, right? and then it runs hello.js, which contains JavaScript. Yes. You also get, once you install Node.js, you get another executable that allows you to install Node.js modules, Node.js libraries, right? Which is the npm executable, right? So you get the Node executable, which allows you to run JavaScript, and you also get the npm executable, which allows you to install and manage libraries, right? And you can go to npmjs.com to see what libraries are out there, right? And there's tons of libraries, right? And this is true for any language, right? Any particular language is not peculiarly interesting, right? What makes a language particularly interesting is the community that has evolved over time around that language, and all the projects and libraries, right, that have been created, right, by the community and shared amongst everybody in that community. This is true for .NET, right, for Java, for Python, right, and also for Node.js. And so npmjs.com is the repository where you can find all the JavaScript open source libraries, right, that are available, and particularly one of the more prominent or more popular libraries is the Express library, which we're going to be using later on in this course, right? This one has, it has what, 22 million downloads weekly, right? And so it'd be great if some of you eventually are able to create your own libraries, your own open source library, right? And folks are downloading your library, right? And you become famous and popular and successful as some of these projects. So hopefully I'll see you one day in npmjs.com. I'll come work for you. So some other libraries that we're going to be using in a minute is the Create React app library, which was created by Facebook, that allows us to very easily create React applications from scratch, right? Very, very easily. And you can go to the repository and see the project. Oh yeah, this is deprecated. We're going to be using an NPX version of this, and also there's a TypeScript version of this that we can use. And so there's tons of these libraries that we're going to be using that is going to allow us to create these projects. Right? Again, I'd love to see you one day for you to be able to create your own library and folks using your library to create their applications. So we're going to be using these libraries to install and create our applications, right? Another executable that we're going to be using is npx. So npx is like npm, but instead of installing libraries, it downloads an executable, runs it, and it can take arguments, right, parameters that are going to be installed and build a boilerplate application that allows us to get started implementing our applications. Are there invitations to the libraries to use assignment? No, you can certainly use libraries that are out there. Feel free to use libraries if they're not addressing a particular task that we have literally asked you to do. Feel free to use libraries out there that you want to explore. So also, if you find something on Stack Overflow that is useful, again, if it's not something that we specifically asked you to do, right? Feel free to reuse code from other sources. Just don't try to fool us into thinking that it's your own code, or as long as you give it a reference saying, hey, this is not mine, I got this from Stack Overflow. And again, if it's not something we specifically asked you to do in your assignment or your project, go ahead. Feel free to reuse. Also, feel free to reuse any source code that I provide and share with you through GitHub. Please refrain from using any source code from other students or other repositories from prior semesters and whatnot. My TAs have been with me for a while. They're very familiar with work that has been done in prior semesters. So please, be honest. Right? So anyway, so we're going to create an application that we're going to be using to implement our web application. Now remember, our application has two large parts, right? It has the client side, right, that we're going to be working in the first half of the semester, and then the server side, which we're going to be focusing on the second half of the semester. Here, we're going to implement the first half, right? So let's head over to a terminal, and I can demonstrate. So let's see where we are, and so I think we can go to NEU and 2023 and fall. And let's create a directory for the graduate folks. So we'll say make directory CS 5610. And let's go in there. And in here, right, let's create our application. And so I'm going to paste the content. Oops, did I copy it? Copy, paste. There it is. So I'm just going to add here that this is CS 5610. And probably might want to say that this is fall 23. Okay. All right. So that's going to take a little bit. That's going to it's downloading the source code from npm JS, right? It's compiling a few things, and it's going to create a folder, separate folder for us to keep working there. If we use, will there be a lot of measures of effect? No, that's fine. So this is the boilerplate code. You want this to be the same for everybody, right? You want this to be the identical for everybody. It's just mostly just a boilerplate stuff that it would take you, hours to set up yourself and install the right libraries and configure them correctly. And so this is something that is really not necessary to do that from scratch. Okay. All right. So we did that, and this created a folder. We can go in there. And we can start the application as follows. We can say npm start. So this is going to start a Node.js server, which is going to host our tiny little web application. It's going to kick off a browser and is going to navigate automatically to the root of the web application, and it's going to render this dynamically in using React.js. Using JavaScript is going to dynamically render this content, right? We can take a look at the content. We can inspect. If you're using Chrome or Safari or any other browser, typically if you right-click, you can look at a option that should be something like inspect, right? Or the developer tools. And if you go there, it will open up another window, or maybe on the sidebar like this, that will allow you to explore your application on the left, right? So this is kind of like the Matrix, right? Where when Neo all of a sudden was able to see how the Matrix really was, right? Here on the left side, you see what everybody else sees, right? And the virtual world, and then here on the right is all the source code, right? That is working together to render what you have here on the left-hand side, right? So this inspector tool, this developer tools here on the right-hand side is going to be your next best friend, right? You're going to have this. You should have this open all the time, as you are developing. Because it lets you see everything. It lets you see all the source code that is rendering this content on the left. It lets you see any errors that get written to the console. The actual HTML that is being used to render the left-hand side. Okay, and also on the bottom you can see the CSS that styles the left-hand side, choosing what colors, fonts, background, foreground colors, right, and the resizing and the spacing between the content, right, is rendered here at the bottom, right? So each assignment tackles different portions of the different languages that we're going to be exploring this semester, right? The first assignment talks about this HTML. The second assignment talks about the CSS. The third assignment talks about the source code that dynamically renders the content here. Okay, right now all that lives in here. Let's open it up with our favorite IDE. Right. So let me open it up. I'm going to close this. I'm going to open up this particular project, and it's fall. We have 5610, and here's our folder that we just created today, right? I'm going to say open that. So this is the source code that is currently running here. So this, right, is looking at this content here, right? And this is the folder that we just created with the project. So this was what Create React App generated. So what did it generate? Well, it created 3 folders, right? A couple of files. There's a README file, very important. It has a package.json file. A package.json file is a giveaway that this is a Node.js project. Okay, it lists any dependencies, any libraries that it's expecting to be installed inside of this project. Like for instance, it's assuming that that React is installed in this folder, right? That it's available, and all these libraries are installed in this directory right here, node_modules. See that? If you open it up, there's tons and tons of libraries that have been downloaded, installed, and compiled, right, and ready to be used under here, right? So, also under here is a 2 folders here that contain source code, right? This public folder is what our server, a little Node.js server that is currently running, that you can see here. This is the Node.js server running, and it's letting you know that it's listening at port 3000, running on your local machine, right? And it's hosting, it's serving all the content that is available in this public directory. Right, so for instance, anything that you drop in here, any file that you drop in here. So for instance, if I have a hello.txt, right, and I put here, hello world, and I save that, I can navigate to that by typing, HTTP localhost /. So that slash there is mapped to this directory, this public directory right there. It's a map to that, right? So I can type in here a file that can be found there. So hello.txt, right? It downloads that that world, and you can inspect, you can see the network, and you can see how the browser is going out to the server, fetching that. So if I refresh, you'll see that there it is. See that? This is the request that went out from the browser. It went out to the server as an HTTP GET request, and the server responded. You can see the response here is a text file. You can see that the response, it's coming back as plain text, right, from the server, and the browser is interpreting this as plain text, and it renders it as plain text. Yes. Now, instead, if this would have been an HTML document, if I rename this to be HTML, right, and I use some formatting here, I maybe format it as a header, as a heading. Okay, oops. There it is. So now it's formatted as HTML, and then I go back here and I ask for that particular document, HTML, right? Is going to come back as HTML, right? You can see the request went out, right? And the response, the server responded saying, "Hey, this is not plain text, is formatted as HTML." So now the browser knows to interpret this and not literally, right, render those headings, that H1, opening and closing tags, but it'll format it and render it as a heading. Yes. Okay. Now notice that when we don't provide the content, if we don't provide any file and we say enter, notice that it renders this, right? You might say, wait a minute, I didn't ask for any particular file. And that's because by default, if you go into a folder, right, and you don't ask for any particular file, by default, the server is configured to give you this file, the index.html file. It's a very specific file without a specific name, right? And if you don't ask for anything in peculiar, right, it will serve you this particular file, right? So this file, it's an HTML document, right? It has all sorts of opening and closing tags, right? And it's formatted as a proper HTML document. It has an opening HTML tag and a closing tag. All closing tags start with a slash, right? And here's another opening tag, the head. So HTML documents have two sections. They have the head section and the body section. The head section is all about all sorts of meta information, right? Who the author is, any dependencies that this file might have with other files. We'll come back to this quite a bit a little later. But the main content is in the body, right? And the body has a div, has a root, right? But it doesn't have all those images. Where are all those images? What happened, right? The content says that you have images that are spinning, right? You have a hyperlink down here. You have this paragraph. You can see it here. You can see the elements have, you can take a look at this, right? Here's the HTML. Here's the HTML. There it is, right? You have the heading. You have the head. You have all this, and there it is, right? You can see that. It's the same content. That's the same content, right? And when you get down to the body, you have this div. And here the div says ID root. This one too has an ID root. See that? But this one has empty. There's nothing in here. It has an opening div and a closing tag. See that? There's nothing in there. But this one does have something. What's going on here, right? You have a header. You have a spinning image. You have a paragraph. You have a hyperlink. Notice that as I hover on the right-hand side, it highlights, right, on the left-hand side, the correspondence contents, right? But there's some magic that's going on here. Where's this content that I don't see here? I don't see it here. Why is it here? Well, it turns out that this is not just plain HTML. There is some React.js magic happening that we won't get to yet until we get to the third assignment. But I just want to give you a sneak peek at it, right? So that magic is happening under the source directory. Source directory, it's all JavaScript, React.js, right? Some magic is happening, and it all starts in this index.js. In index.js, we have JavaScript that on the browser, this is running on the browser, and what it's doing is that it's going out to the document, the HTML document, and grabbing an element by its ID, right? This root, which it's right here, right? Oops, in this right here, right? This index.js is going out to the document and the root, which is right here, this root. See that? It's grabbing that element by its unique identifier root. And what is it doing? It's creating a new instance. And then in that root, right, it's injecting this content in there, right? Something about some strict mode, but the main content is this app. So this app, it's right here. It's importing that JavaScript file, which is right here, this JavaScript file, app.js, and there it is, right? It's a function that is returning, it's calculating the outputs, right? And it's responding with this HTML. See that? There's our image. See that? There's our paragraph. There's our hyperlink. See that? And that's what we're seeing here, the paragraph, the image, which is being injected dynamically into the root. It's being injected into the root. And that's why you see something that it's inside of the root. And then JavaScript is inserting this content dynamically in there. See that? Well, we won't really get to this until we get to the third assignment. So for now, in the first and second assignment, we're going to break this because we don't want to know anything about JavaScript just yet. We're going to comment this out. Comment this in that says, I don't want this. We're going to break this. And notice that now, boom, it's not rendering anything. It's blank. There's nothing to render for us. It's just rendering our plain old root. See that? Nothing is being injected now, right? Because I broke it deliberately. So we're going to go back to our index, and we're going to do something. We're going to comment it out for now because we're not going to do anything with it just yet. Well, I guess we could leave it out. We could leave it. It doesn't matter because we're not doing anything with it. But now we can start typing our own HTML. We can say, welcome to web dev. Let's save that and go here. Notice that it's being rendered as a sample H1 elements. And we're going to start working on our first several labs. Inside the public directory, we're going to create a couple folders, right, where we can work on the labs, right? We can work on the Canvas application, right? In the labs, we're going to create a couple other folders, right? For the first assignment, for the second assignment, the two, right? And the third assignment, well, actually, we're not going to, once we get to the third assignment, we're no longer going to be inside the public directory. We're going to swap back into our source directory, right? But the first two assignments are going to be under here. And so we're going to create under the first assignments, right? We're going to create another index file, right? Where we're going to have, say that this is lab, assignment 1, right? And we want to be able to navigate there. So we should be able to navigate slash labs A1 index, right? So we should be able to do that. We should be able to say, slash labs A1 index. Actually, we shouldn't even need to provide the index file, right? We're going to say enter. Notice that we have it, assignment 1, right? Because if I don't ask for a specific file, it will give me the index, right? Index.html. And there it is. It's this one, right? Now we don't want to make it. We want to make it easy for our TAs to find our assignments. So from our landing page here, our top level index, we're going to create hyperlinks that will allow us to navigate to the assignments. We're going to say we're going to be able to create a hyperlink, an anchor that is going to allow us to navigate to assignment 1. So here we're going to provide the navigation. We're going to say, labs A1 under index.html, right? So there it is. So if we click that, the TAs are going to be able to navigate down to each one of the assignments. Make sense? Now, in the assignment, you're going to go through the various exercises that are listed here, right? Where you're going to learn about headings. You're going to learn about paragraphs and the lists, rendering tables and lists, right? And rendering all sorts of images and also form elements like input fields, text areas, sliders, drop downs, date pickers, blah blah blah, right? So if you could, perhaps during this weekend, right, if you could complete perhaps the labs on your own, we're going to come back in the next lecture, right? We're going to revisit this and see where we left off, right? And so we're going to be ready to start working on the Canvas application in the next lecture. Okay, the Canvas application is going to work towards implementing several of these screens just with plain HTML. Just plain HTML. Right? At first, it's going to look ugly like this. Right? It's going to look awful, right? It doesn't have to look like this just yet, right? We're going to do that in the next assignment. We're going to take this ugly implementation in the first assignment, and we're going to use in the second assignment. We're going to use CSS and Bootstrap, right, to make this look pretty. Okay. All right. Let's leave it at this. For today. Any questions?
Hi, Professor. I have a question regarding to the final project.
Yes, sure. Just real quick, Helen. Yes, this recording when I stop recording, it'll be available in Zoom. Actually, no. What I'm going to do is that I'm going to make this available. All recordings will be available in YouTube, Facebook, Twitter, now X. So I'm going to make it available in different places. So however you want to consume this, it will be available in your favorite application, streamer. I'm sorry, go ahead.
Yes, so my question is like, what are we gonna submit for the final project? Like, are we gonna have to write something like an essay or like a project proposal, or are we going to do
No.
Okay.
Yeah, no essay, no anything like that. So basically, we just give you a list and we give you a project requirements, and you just have to meet those requirements. You have to build your application based on those requirements.
Okay, cool. Thank you.
Sure. Yep. Till 3.1 is what we have to do for the assignment, right? Do we do 3.2 also for assignment 1? 3.2. No. For assignment 1, you're going to do the entire assignment 1. Yeah, and I will get you started, right? So in the next lecture, we're going to start working on, we'll do a few labs, and we're going to get started on the Canvas application. We're going to cover HTML formally, right? And as we work through Canvas, we will introduce various HTML elements. For instance, when we get to grade screen, we're going to learn all about tables, right? When we get to the home screen, we're going to learn about lists, right? And how to create hyperlinks, how to make lists within lists, right? How to implement form elements like drop downs and buttons, and that if you click a button, it allows you to navigate elsewhere. So yeah, as we introduce these, you'll learn about the various HTML elements. Do we have to only submit the source code? No. So the what we're going to do is that we're going to once we complete the source code, we're going to share all the source code in GitHub repository. And once you have it in the GitHub repository, we're going to deploy that into a remote server hosted by Netlify, so that your application is not only going to run locally on your machine, but it's also going to run in a remote server, so that anybody can visit it, anybody can see what you've been working on. And by the end of the course, hopefully this would be kind of like a portfolio, right, of everything you've been working on, and you could use that perhaps with a future employer. Well, no, the textbook does have certain exercises that are referenced throughout the assignments, and the quizzes might have some questions about some more theoretical things that are go in more detail in the textbook. All right, everybody. Thank you. See you next lecture. Right. Again, if you can get started on this first assignment, it'll be great. Good night, everyone. Thank you.
Thank you.